that's some real popcorn stuff right there. I don't even know how that held at all. There's like nothing. This is how it was. They welded that at like 10 amps. Let's see if the Lincoln 180 and the Solix F3800 are up to the task. So we got a 240 volt output, 6,000 watts. Should handle this. I just had to make up this little extension cord here to convert that to that. Gonna be running this at max amps, 3.5 speed. Should be around 5,500 watts or so. We'll be able to see because this will tell us how many watts it is for the output. Right now, just with the fan running, it's 30 watts. So this started out where I needed something to be able to weld this bracket onto here, and I have a 120 volt welder that I was going to bring in here and run off an extension cord, but that thing doesn't really do a great job on thicker stuff, which this is about 3/8, 7/16. So I have a generator, but I've run welders off of generators before and they don't do a great job for some reason. The power's not clean enough and they end up just kind of skipping around and you get popcorn welds. So then I got thinking, well, maybe I should get a generator with an inverter, but those are pretty expensive. So I was like, well, let me check into one of them power stations. So that's what led me to this Anker Solix F3800. And the capabilities of this were pretty impressive when I read about them. It's 6,000 watts of continuous load that you can get out of it at 240 volts. Plus, there's a surge on there, which I think is twice as much as that, which is good for like AC compressors and electric motors and stuff like that. So this thing is pretty nice. It's got this plug for like an RV, and then it's got this for 240 or 120. And then it's got 6 outlets, which are all 20 amps. You can tell they're 20 amps because the little prong goes to the left there, which I don't have anything that's dedicated for 20 amps like that, but it is nice that it has that because there's some devices that you can't plug into a regular outlet without that. So this unit also has 2 MPPTs on it for solar, and you can put up to 2,400 watts of solar into this one, 1,200 in each port here. And I actually got 2 of these units, and so all together, when you hook them up together, you can get 4,800 watts of solar. This unit has 3,800 watt hours of storage in it, and you can expand the batteries, and they're each 3.8 kilowatt hours a piece. So you can stack a couple batteries on top of this and you can get quite a bit of storage out of it. And then if you have 2 units, then you can obviously have double the storage. So I'm gonna get into reviewing and testing this thing later in the video, but for right now, I wanna get the electric installed in this garage. So let's go ahead and do that. So in this video, we're going to be installing the electrical components to this garage. We're going to be installing the service, which is 150 amps coming in right there. On the other side of that wall is going to be a load center, 150 amps. And then from there, we're going to feed another panel across on the other side of the building, which is going to be in a utility room. So let me show you the one-line diagram. So here's the one-line diagram that I drew up for this garage. I didn't have to draw this up for anybody. I just wanted to do it for myself, just to kind of figure out everything, because it's a little bit complicated how I want to do this. So here's the meter that's on a pedestal out in the driveway. I'm going to run from there to my first panel, which is going to be right next to the door. That's where the conduit comes up on the southeast side of the building. So we're going to go into a 150 amp load center, and it's got a 225 amp bus, which is important because we want to backfeed some solar. And out from there, we're going to have a few circuits: welder circuit, 50 amp, and a 30 amp welder circuit. 50 amp is for plasma and the stick welder, and then the other one's for the MIG welder. And then we'll have a few other receptacles, probably not any lights because we want to back them up. So from there, we're going to run 1113 SER cable, it's aluminum, to a 100 amp sub panel, which is going to have a 125 amp bus. And from there, later on, we're going to do a line side tap into an inverter, and we'll feed that from some panels up on the roof. We're going to have a big solar array on the roof, so we'll do that later. But just to explain, how things are going as I'm moving along here. So this is a sub panel that's on the other side of the garage. So from that sub panel, we're going to have a bunch of other circuits, like a 50 amp welder circuit, same thing like on the other side, the 30 amp welder circuit, one for the plasma, one for the MIG welder. We're going to have a compressor, a bunch of receptacles. We're also going to feed this Anker home panel, which basically allows you to take two F3800s and combine them together and get 12,000 watts of output and 12,000 watts of backup into this panel, which will then feed this panel for a critical loads panel. That's going to be another 100 amp panel. And by the way, the solar panels will go directly into the F3800s. And then the critical loads panel will power, outdoor receptacles, indoor receptacles, 30 amp welder circuit, small water heater circuit, and then also I'm going to have a mini split that's going to run on that. And that's the main purpose for having this automatic backup, is to be able to run a mini split when the power goes out. That way I can keep this building above freezing, because I'm going to have things that can't get frozen. So I wanted that for the automatic backup. That way if I'm not here, it automatically just keeps on running that mini split, along with some receptacles and lights and stuff. I'm going to run all my lights into the critical loads panel. I figured, why not? So feeding from this sub panel to the Anker home panel is number 2 copper. Feeding from there to the other 100 amp panel is number 2 copper. And then number 1 between this sub panel and this main panel in the front, which is also a sub panel, but we'll just call it the main panel for now, just because that's the main incoming power for the whole garage. So I think I've explained everything that I got on here. Sometimes when you're doing a solar setup, your power company will want something like this, is a one-line diagram. But even just for yourself, sometimes having something like this kind of takes the confusion away, cleans things up, and really spells things out so that you're not missing anything as you're going along. You don't want to try to make this up as you're going along. It took me a little while to figure this out, because I wanted to be able to backfeed from this inverter here with panels on the roof into here, and then backfeed and actually feed the grid from here. So this will be a grid tied system. I'm not sure if I'm going to just do a regular grid tied inverter or a hybrid. Not really sure. I don't really need a hybrid, because this right here is actually kind of like a backup, plus it has solar, but it will not feed the grid. So I need another at least grid tied inverter. But I don't really need the hybrid, because the hybrid would be a backup as well, which I already have the backup here. Which is nice, because a regular grid tied inverter is much cheaper than a hybrid. So You can save a lot of money by just doing that. And then we'll have panels on the roof for this system, but we'll also have panels on the roof for this system separate. So now that I've explained exactly what we're going to do, let me show you where we're going to put all the components. This is the utility room right here. It's pretty dark right now, but basically we're going to line up on this wall all the different panels. This room is kind of tight because it's only 6 feet wide and about 8.5, 9 feet this way. But we're going to fit all the panels on this wall. This door is going to open to the outside, so it's not taking up any space on the wall. We're also going to have the inverter on this wall. And then on this wall we're going to have all the radiant heat accessories. Geothermal system over there and tank right here. And then there'll be some plumbing pipes right there for the bathroom and sink. So we've already drilled holes going all the way around the building at 3 feet, which is normally what I like to do because 3 feet is good for both the switches and the outlets. You go a foot up for the switches and you go a foot to 18 inches down for the outlets, which in this case we're going 2 feet off the floor, so it's a foot down. Normally it's around 18 inches off the floor for a residential dwelling, but this is not a dwelling, so we're going to make them a little bit higher. So I drilled a 1-inch hole all the way around the building. And we snapped the line just to make it look good, but you don't need to do that. And so on all these exterior walls, I'm aiming for an outlet about every 16 feet, which normally in a residential house you would do less than 12 feet. And it's required to be less than 12 feet for a lamp to be able to plug in at any point in the wall. But this is not a dwelling unit, so I can do whatever I want in here. Basically, if you put electric in a garage, the only thing you're required to do is put a light next to each door. So I'm gonna get the guys going on installing all of the boxes and running all the wire to all the outlets and switches. And I'm gonna get going on the more complicated stuff, which is the load centers, or the panels if you will. And just a reminder to you guys, I say this on every video where I do electrical work, I am a licensed master electrician, but I don't do it full time. So being that I don't do it every day, there's a lot of things that I'm missing out on, like certain products, certain new ways to do things that are more efficient or more cost effective. I know how to do things to pass code, to pass inspections, and I can do it in a legal way. But that doesn't mean that everything that I do is exactly the most efficient or best way to do something. For instance, Square DQO is one of the best panels that you can install, but they don't have a 150 amp QO panel that's readily available. So I went with the Homeline, and since I'm going to go with the Homeline for the 150 amp that goes in there, I'm also going to do the 100 amp that goes over there, just to keep it simple and have all the same breakers for all of them. But yes, a QO panel is definitely better. So I'm liking this layout here. This looks pretty cool. Everything's nice and symmetrical. They did give you a panel to use as a critical loads panel, but it's a main lugs only, which means it doesn't have a breaker. And you don't really need one, but at the same time, for $100, I just put that panel in, and it uses the same breakers as that one, uses the same breakers as the one in the front. So, you know what, for $100, it just eases my mind a little bit. Makes things look better too. Plus it does have more space in it, which I don't think I'll need, but just in case I do. So at this point, we need to run conduit from here to here and from here to here. We're gonna run 1.25 inch because that's the minimum size that you need to run 3 number 2 wires, number 2 copper, and then 1 number 6 for the ground from here to here for 100 amps, and then for 100 amps here. So we're gonna come in with 100 amps to this and go out with 100 amps to this. And you can get away with going out with less than 100 amps, but I believe the way this works is it will bypass 100 amps. I'm not totally 100% sure about that, but for the little bit of extra cost for the bigger wire, instead of running 50 amps, which 50 amps is the max that this system will run. I'm gonna have the F3800s down here, and 2 of them together, parallel, will run 50 amps. But I'm pretty sure that you can bypass more power up to 100 amps going to that panel. So that's what we're gonna do. And like I said, 1.25 inch conduit is what I'm going to use, PVC. And the knockout for this one is here, and the knockout for this one is here. So I made them perfectly level with each other, but we do need to offset that conduit with like a 22.5 degree and then 22.5 degree the other way, simply because this one is out further. Plus this panel is just deeper than this panel. So they're offset by about 3.5 inches. So I need to bend up 2 pieces of conduit that can do that. So this would be another good test for this, because this is 1500 watts. I'm running a fan right now and some lights and stuff, but it can handle a lot more than that. That's like 1/4 of its capacity. And that's only 1 unit. And then you double it up and you got 8 times the capacity. So you could actually run 8 of those at once. I got 2 pieces of 1.25 inch. I don't know the total length on them yet, so we're just gonna bend them up. And I did measure, and we need a 3-inch offset. So I'm gonna take 2 2x4s and stack them on top of each other, and that'll give me my reference. So we know if we're flat on the bottom and flat on the top, then we got our offset. That's about the shortest you'd want to go with that kind of radius on that, but I should have done like another 3-4 inches. Would have been a lot easier. I kind of struggled to get those bent the way they are. So now that I got this done, this panel needs to go here, and this panel needs to go here. So it's kind of the opposite of what you would think, but it's fine because I'd rather have a little bit more of a loop here than anything. And I wanted that panel there because its feed is going to be coming from that way, so I didn't want to go all the way across like that. So I think it's better just to have this. So for a 100 amp service, since it's not feeding a residential dwelling area, you have to account for the full 100%, not 83%. So in other words, normally number 4 would be fine, but in this case, number 3 is really what you need. And since stores don't carry number 3, then you gotta upsize it to number 2. So it's 2 gauge coming from this panel to here and coming from this panel to here. And that's why we had to go with 1.25" conduit instead of 1 inch. So if this was in a house and you were doing this, you could actually get away with number 4, and you could use 1 inch conduit. So you can install this mechanical lug, and basically you put that in there, and then that gets screwed into there. You can also crimp the ends of here, which I do have a hydraulic crimper, but I don't have the right connectors, and rather than go into the store, I already have these laying around, so we'll just use these. Okay, so line 2 is going to be black, line 1 will be red, so you got to phase tape that. 2 pieces of tape towards the end where you're terminating is what's required. So I might as well put it on now before I put the wire in there. It's a little bit easier to do it ahead of time. So for some reason these panels never come with these ground bars, or a bus bar if you want to call it that. I guess they assume that you're just going to share the neutral with the ground, but these are like a sub panel, so they should come with this, but you just buy this separate and you just screw it into the side wherever you want. You can put it on the bottom or either side, or even on the top if you want. Because remember, this is a sub panel, so you cannot combine the grounds and the neutral together. Sometimes if the ground is big enough, you got to put a mechanical lug on there, but this is just number 6, so you can put it right into the ground bus. So that's basically it. Now you need to do the same exact thing on the other side here. Same exact process, just you're just coming from the right instead of the left, so you're gonna cross over this way. The only difference is in this panel, you're feeding this panel from this panel, so you're gonna be coming off a breaker, which I'm just gonna put right on the bottom here to make it easy. You're not going into the top like you were on the other panel. So it's a little bit shorter of wires. That's a 100 amp breaker. So I'm gonna attempt to hook this up to this panel. I don't know if it's gonna work without the power coming from the main panel, but I got one circuit in here. Let's see if we can power that from this F3800. So they give you this huge cord right here to connect this to that panel. That's a nice positive lock right there. And even with those panels sitting way up there, there's still plenty to loop around here. So, turn that on. Breaker number 1 on. In the meantime, though, we are setting up lights and outlets. So I'm going to be using 2 lights on this area, and then I'm going to have 3 and another 3. So we're going to use 8 altogether. So we got our 1113, which is 1 gauge with a number 3 ground, and it's also a number 1 for neutral. This is SER wire, and this is going to be run from that panel over there to that panel in there. And then we have 4/0, which I was going to go with 3, but it was actually cheaper to go with 4. So 4/0 is good for 200 amps if you're feeding a dwelling, because of the 83% rule. But since we're not feeding a dwelling, it needs to be at least 3/0 to get 150 amps. And we could go up to, I think, 175 amps, but that's not very popular. So we're going to go with 150. And this is XHHW. Instead of getting a USE 2 cable, which is usually what I do, it's a quadplex. So last night I installed this power station, the F3800, and I hooked it up to the panel, and it won't fire up this panel, I think, because to do the startup procedure, I believe you need power coming in. So we don't have that yet. Once it's all configured, obviously it can run without the power, because that's the whole point of it. But I think for the initial startup, we need to get power going to this panel. So that means installing the panel over there next to the door, and that also means installing the electric going to the meter, which is 200 feet away. So we need to get all that done. So we need to run the SER cable from that panel to here. But before we even do that, because that's indoor work and we got rain coming up, I want to install our conductors going from here out to my main panel, which is the meter over there. So if you've been following this garage build, you know that I already installed the conduit going most of the way out there. That I did that when I put in this driveway here. But we need to continue it from there over to the panel. So that's the meter right there where we need to get to. We left off right here because this is actually, it's all overgrown right now, but this is the overflow to this pond right here, which you also can't see. The overflow comes down here and around there. It goes through a culvert pipe. And in order to cross this, we need to put in more culvert pipe to extend, which I want to do anyways, because I want to round out this corner here, because right now you can't make it around this with a truck and trailer or a big truck or anything, because it's only 10 feet wide here. So I'm gonna install a culvert in here. That's 20 feet. I'm probably just gonna come out about 12 feet here. That way I can cross with the conduit and go into that pedestal right there. And then I'll take the other 8 feet that's left and I'll put it on this side so we can extend this as well. But we can't cross over without that culvert in there, because otherwise you'd be crossing stream. So I just got to dig this out a little bit, get the overburden out, install that culvert, and then we can cross this with the 2-inch conduit. And then we got to dig across the driveway here. So I want to get everything done before that, because I don't want to have no access to my house for longer than I need. Tell me for 40 years I could have had you going up a ladder instead of struggling?
Ain't no way. Ow. You telling me for 40 years I could have covered my wire in grease? That's pretty bad right there.
I would suggest putting that to the left side of your ladder before you get too far. There you go. Now you can do whatever you want. Well, we got a lot of excess there. It's showing through to the wire. Or yeah, leave it about like that. That's good.
Macaroni, that's hot. This one's gonna be nothing else.
Slide it. I think I'm gonna have to go as far as I can.
Here. Go this way. Where are you? Hey! 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 Okay, it's through.
If you just take 10-15 minutes and build something like this real quick, it'll make your life a lot easier. We got about a 220-foot pole here, so we don't want anything fighting us. We already got the wire fighting us. We're gonna hook up a vacuum to this end, and on the other end I'm gonna put this mouse. We're gonna run this mason line through. We're gonna use this mason line to pull a mule tape through. This is a flat tape so it doesn't carve into the pipe as you're going, which does happen. Especially if you're using like a cable, it'll cut like a line into the pipe, but this won't do it because it's flat. And this is good for 1,250 pounds, and this is 3,000 feet. And this was only like $120 for 3,000 feet, so it's worth getting this. So we just use the mason line to pull this, and then we use this to pull the actual wires. Good. So the name of the game is lots and lots of lube. So I left a bunch of this mule tape sticking out, and the reason is I want to wrap it a couple times around my tracks, and then that way I'll use the tracks to pull this like a winch. So you just put the blade down, put the bucket down, lift the tracks up, and then it's easy. Real slow and see how it goes.
Okay, there you go. And we're off. Damn, yo.
Everything going all right?
So far. Hold on, slow down. Seems to be going. I said seems to be going. Apply a little more lube here. Good?
That should be good there. How much you got left? Plenty?
Plenty.
Alright, I'm gonna go a little bit more then.
Alright.
Good.
Good.
Yeah. It can go up. All right, that's good. That's good.
That's good. You want some lube for that?
Nah, it's not really that. It's just it's the bending, especially in this offset right here. I got this thing twisted. Hold on. I'm gonna get it in here first. So I got my panel on the front side here, which is a combination meter pan, 200 amp. And on the back here, I'm going to be putting this new panel on. And I'm just going to come through right here, the 2-inch conduit, from one panel to the other. Start hooking things back up again. So now I'm going to feed this panel from the other side with 2-aught, and I'm going to downsize this breaker to 175 amps because that's about all 2-aught is good for, 2-aught copper. Unless you're feeding the house, then you can go up to 200 amps, but this is a 200 amp breaker here, so I got a 175 amp breaker on the way. I'll just replace that once I get that. And then these feed through lugs are going to go to the new garage, and then that will be off this 175 breaker, which is nice because I ran 4-aught to the garage, so 4-aught aluminum, so that's good for 175 amps. So that protects that plus everything else in here. All right, so we got power going up to this panel. Turn this breaker on, turn this breaker on, this breaker on, this breaker on, and this breaker on. Let's see here. There we go. Cool, okay, so we got our backup load on here, we got our grid. We're just missing the power station 1, which, let's see. Okay, so I found the home power panel. So, okay, so I didn't realize that I actually unplugged it the other day, so I'll plug that back in. And now, there we go. All right, well, while I'm getting this set up, I'm gonna run some of these circuits into these panels so that we can actually test things out.
got the Anker, that's it. Or 630.
That's super solid. I like that. You know, a lot of people would run this sort of thing in conduit. They'd run EMT, but I'm just not into that. Everything's gonna be covered. This is all gonna have like metal siding or metal roofing on it. Just like on the roof and just like on the outside, I'm gonna have white raised rib panels. And I put these at a spot where it's just before one of the raised ribs. I measured it out and the raised rib's gonna be right up here somewhere. So it won't be part of that raised rib. All these outlets are gonna be like that. But there's no point in running this in conduit if I'm just gonna cover it up anyways. Which I may not even cover it up for a while. That may be this winter that I do that. And I may get the CO before that. I may actually just spray foam the walls with 1 inch of spray foam first and just leave that until I got time, like later this winter or something. But in any case, because it's a garage, I can just leave this exposed like this as long as everything is stapled the way it needs to be. And this is really solid. The only problem with using a metal box is you gotta ground it, but that's no big deal. And just to let you guys know, this is aluminum. This is actually XHHW wires. It's 3-wire, which means there's 3 bigger wires and 1 ground. So you can see that's XHHW-2 XLPE, and this is a SE cable. So this is good for 50 amps, and it's a lot cheaper than buying 6.2. And I only need 6.2 copper for here. If it was solid copper or stranded, 6.2 would be good. But in this case, even aluminum at number 6 is good because this is rated for 50 amps at 75 degrees Celsius. So as long as this is rated for 75 degrees and the panel's rated for 75 degrees, then we're good. And I don't have to step it down to number 4, which usually you gotta step it down with aluminum. But this stuff was half the price of 6.2. This stuff was like $1.10 a foot, and it has an extra wire, which I don't need, but it's good for other stuff that needs 3-wire. If you were to just buy 6.2, it's somewhere around $2.50 to $3 a foot. So it's half the price, and you actually get an extra wire too if you need it. So that's why I'm using it. And some guys will use it for dryers and range tops and ovens and stuff like that. And it actually is easier to work with than 6.2 as well. But the cost is what drove me to get that. So this area right here is going to be a workstation for the welders, plasma cutter, torches, that sort of thing. So I'm going to actually run, this is 50 amps, and I'm going to run another one of these, same exact outlet like this, but it's going to be 30 amps. And that's going to be for the smaller welder, and this one is for the plasma cutter and the bigger welders. It's 50 amps. So I actually hooked this up to the backup panel inside of that utility room there. So I did that purposely because I wanted to test it out. This is the backup panel that's coming off of this panel. So that's gonna run purely off of these and nothing else. So we're gonna get into testing these in a little bit, but what I wanted to do is run the necessary cables and outlets and stuff to be able to test these out, because together these should put out 12,000 watts. And the only way that you can do that is going through this panel to get to 12,000 watts, because this panel combines these two together. So I needed to get all this done in order to do this. Now you guys saw me in the previous video, I was running off of one of these. I was running my smaller welder, that's the Lincoln 180, and that only requires about 25 amps, which one of these is good for 25 amps at 240 volts. Two of them together are good for 50 amps at 240 volts. So that's what I'm after testing, is two of them together. So the idea is that I wanted two outlets here so that I can have a dedicated one for the plasma cutter, and I can also use the MIG welder at the same time without having to unplug things. And if I want to switch over to the Lincoln stick welder, I have a DC Lincoln stick welder, which I got to bring over here. Then I can unplug one of the welders from the 50 amp. I believe that requires 50 amps. So I could put 3 plugs here, but I don't really use a stick welder that much, so it's not a big deal to just unplug one to plug in the other. So the idea was to have 2 plugs there, 30 amp and 50 amp. I want to have another 30 amp plug right here for the MIG welder. And then on this side, I want to run off of that panel, come over to here, and run another 30 and 50 off of here. That way it kind of divides the building up, and I don't have to go too far with extension cords to run welders wherever I want in here. So I have enough extensions that are 30 amp to run that MIG welder pretty much anywheres from anywheres. But it would be nice to not have to do that, and it would also be nice to be able to run the plasma cutter or the stick welder wherever I want as well, which I'll make up some extension cords for them. Just because even with one here and one over there for the 50 amps, it's still obviously a long ways in between there, but it's 40 feet across here, so you're not really gonna do too much. You could have one every 6 feet on the wall and it still wouldn't get you what you need. So I still need some extension cords, but at least if we have one over here, it divides the building up by about half. And like I said, I might get my CO before I actually cover these walls for several reasons. Number one, they tax you more the more finished it is, and you don't need a building permit to put on coverings on the wall, so why get involved in that? And number two, it's just not necessary right now, so if I can get away with not doing that, then that's all for the better. And I see a lot of shops that are just spray foam on the wall and that's it. Now in a house you can't do that, any kind of dwelling area, but in a garage it doesn't really matter. So that's why I'm gonna start putting on these metal cover plates, because in a garage, if you don't have a wall covering, then I believe they're gonna make you put metal wall plates, because they're kind of like exposed and you could break them pretty easily from the side because there's not a wall to kind of back up the strength of it. So I'm gonna end up putting metal wall plates on everything for now, and then we'll see if we can get away with not doing a wall covering for right now, and that would be nice. That would save me a lot of time. So like I said, I want to do some testing on that system, but right now I want to finish up a few more things. Number one, I want to get all these lights installed. So Hyperlight sent me 9 of these lights, and I only have one installed, and it's just kind of rigged up right now. I got some outlets run where I want the lights. So at this point, really all I have to do is start hooking up the lights, and then I just have to hook up the switches here, and the circuit is already hooked into the panel. So we're pretty close to having lights in here, and it's gonna be dark in a few hours. So let's get the lights on, and I'll show you guys those. And we'll run those off that panel too. So like I said, I've had this one up for almost a month now, and I'm really happy with how bright it is. These are, I believe they're 150 watts a piece. So we're gonna put up 8 of them. So it's gonna take a whole 15 amp circuit just to handle that. And I switched each light individually because I don't want any lights on that don't need to be on, because 150 watts is still quite a bit if you don't need it on. So every light has its own switch. So we're gonna install these, and then we'll run all of them. And we're kind of reviewing these, and we're reviewing the backup power, the Anker Solix, at the same time. So we'll kind of use them together and see how they work out. Because some of those portable power stations, they do flicker, but this one does not. Not as far as I can see anyways. So I specifically wanted a light that didn't get hardwired in. I wanted one with a plug on it. There's a lot of LEDs on there. And they actually give you a motion sensor for the middle there. You just unscrew that like Phillips head looking thing right there, and they have a motion sensor you can put in there. But I'm not going to use that because these are so far up in the ceiling. Plus, I don't like dealing with that kind of stuff anyways. I just want to turn it on and have it on. But that's at least a 6-foot cord that they give you with it. And I'll show you the mounting hardware. But just to circle back around to the reason I want a plug on there. For instance, there's a light that goes right there. And you can see I got a lot of stuff going on right there with the crane and the telehandler and stuff. So if that light was fixed and I couldn't move it, then that would not be that great. But right now, if I need to move the light, it's gonna be plugged in, so I can just move it aside and put it back when I'm done, or I can leave it there, whatever. Like I said, it's hard to set up a garage like this. You got this big wide open space and you don't really know what to do with it. So you kind of figure things out as you're going. So things like having a plug-in light is nice. So each one comes with this hook and its own Allen key. And that hook screws into here. And then you just have to put a hook on the ceiling, and that goes through there, and then you tighten down this screw. And they also give you this tether, like just in case something happens with that hook, like it gets knocked or something, this prevents it from falling off the ceiling. So you put that on the hook that you put on the ceiling as well. So I ended up just getting these hooks. It's probably a better idea to get a closed hook, but this is just what I got, so we'll just use a tether with it. That's it. Alright, so I'm going to do that to the rest of them, and then I'm going to hook up the switches, and we're going to try this out, because it's going to be dark here soon. And I got to take that one down, because that's too low. I thought, usually LEDs, when you put them really far away from whatever you're working on, they don't have a lot of light. That one has too much light. I need to put that one up further. I thought having it on the ceiling wouldn't be enough light down where I need, but like I said, that's too much light, so bringing it up the 4 feet that it needs to go is what I need to do. And that's the light that replaces it anyways, so we're going to take that one out.
I know that does it.
No, what do you got there?
He likes to swim on. No, let's swim.
You guys bring a piece of plywood in here?
Yeah. Yeah, so you have a raft.
A raft for what? The duck?
Yeah. The raft.
Bring him over here.
He's a baby mallard duck. Okay, well, I'll just set him down. He's a baby mallard duck. Good I keep forgetting you just gave me a haircut. It's a white baby duck. You like it? Want to pet it?
I don't know if I can really pet it. I'm kind of too big to pet it.
I tried to sleep, but my head is underwater.
Follow you?
Yeah.
Here, swim away. Let's see if he follows you. Yeah, he sure does.
He follows both of us. It depends on who he's
Right on your
closer
tail.
to. What? It depends on who he's closer to. Like if he's closer to me, he follows me. And he'll actually sit on our backs until they submerge in water. Oh, how could we come by it?
So we're going to do some testing on this system. This is a plasma cutter and it requires a 50 amp circuit to run. And this is an LTEC, which is the same exact thing as an ESOB. So this is a 750i LTEC. So I doubt it's going to come anywhere near a full 50 amps, which would be 12,000 watts. But I'm assuming it's going to be somewhere around 9 to 10,000 watts. So the first thing we're going to do is test to see if this will run off two F3800s, and then we're going to also run, or we're going to try to run the compressor at the same time. The compressor uses about 2,000 watts. So between this and the compressor, we're probably pushing the 12,000 watts of capability that this has. So this plasma cutter will cut up to, I think it's 1-inch steel with one pass. So we're just going to try to cut at the max output, which is 50 amps. And the compressor's going to kick on, so we'll see if it'll hold up. All right, going again. All right, we're gonna try the stick welder now, and that needs 50 amps too. Hopefully it'll pull a little bit more than the plasma cutter, because that was only using about, what was it, 8,000?
I
A
mean,
little
that
less
and
than
the
that.
compressor was like 9,800.
Yeah, so that's like 7,000 really. So hopefully this pulls a little bit more than 7,000. I'm gonna crank it all the way up.
Way less.
Less?
Yeah.
What was that?
It was using 4.8 kilowatts.
What?
Yeah.
Huh. Well, we gotta do something to draw a lot more power. I'm gonna turn on all the lights.
Just the thing running with the fan on is using 500 watts plus the lights that are on in here. 1.63 kilowatts right now.
I'll plug a space heater in over here.
There's 1,500 watts right there on high. good?
I could switch back to the plasma cutter because that with the air compressor and the lights on and that might actually be pretty close.
Yeah.
All right, let's do that.
Okay.
I need that.
All right. We hit 11:53. Yeah.
All right, so that was a good little test that we did there with the plasma cutter. I had the compressor running, which was 2,000 watts. I had a space heater running, that's 1,500 watts. I had all the lights on in here, that was about 1,200 watts. So altogether, we reached, the highest that I could reach was basically 11.7 kilowatts. So that's pretty close to the 12 kilowatts that it was rated for. And I did it for a little while and it was no problem, which it's rated for 12,000 watts continuous, but it's supposed to be 6,000 watts on each leg. If you have 6,500 watts on one leg and 6,000 watts on the other leg, then it might not like that and it might shut off. So it was kind of equaled out because the light circuit was like 1,200 watts and this circuit was like 1,500 watts. So that's one of each leg there, which kind of equaled it out for the most part. And then the compressor is 240, so that's two legs that's split between. And then obviously the welder is 2 poles, so it's splitting that between 2 legs. So it was pretty equal. So that's why it didn't trip anything. But nevertheless, that's pretty impressive for a portable power station like this. Now you couldn't really bring this out on the road on the back of your truck and do that because you would need that panel there to combine them to get the full 12,000 watts. But still, just having one of these with 6,000 watts and throwing that in the back of your pickup truck with the Lincoln 180 or just, you know, a 30 amp welder, that works pretty good. Like I said, I've used welders with generators before, non-inverter generators, and they just don't seem to really work that well. I don't know what it is. The power is just not clean enough for them, so they don't really weld that good. But this had no problem at all because it's obviously an inverter. It's clean power. So each unit has 3.8 kilowatt hours of storage, and then that battery pack has 3.8 kilowatts. So altogether, it's like 11.5 kilowatt hours. So that's a good amount for this garage for a backup. The main reason why I wanted a backup in this garage is because I'm going to have a mini split that's running the cooling for the most part, but in the wintertime I'm going to be using radiant. But if the power goes out, I don't really have a great way to use the radiant heat in here because I'm either going to have a geothermal system, which is just going to be probably too much power to run on that, or I'm going to have an air to water heat pump, which again, I'm not sure if it will really run on that. But I'm going to have a mini split, and in case the power goes out for a while, I need a way to heat this garage because I'm going to have stuff in here that can't get frozen. So I need a way to just keep things above freezing, and I'm thinking that the mini split that I put in will do a good job of that. I could set it at 50 degrees and leave it, and that power station will run that for quite a while because I'm getting a really efficient mini split. I'll show you guys that in a few videos, but that's going to be a solar mini split, solar hybrid mini split, so it actually runs on solar panels during the day that you plug directly into it. But that'll be its whole video by itself. And just know that it's a DC inverter mini split, so it's going to be super efficient, and it doesn't cycle. The compressor ramps up or down depending on how much heat or cooling it needs. So it'll run down to like 200 watts. So that's why I figured this system can run that mini split for probably at least a day before you have to recharge it. And also we have the lights, I have a welder plug, I have some outlets run off of the critical loads panel, which will be the one that will work if the power's out. So what I'm also going to do is install a generator input port right there. That way I can just stick a generator outside and recharge this system. That's what I really like about these systems, because running a generator all the time, when there's no load on the generator, you're just wasting fuel. So to have a generator just run for a few hours and charge up the batteries, if the power's out for like a week, you charge up the batteries each day for a few hours, and then you just shut it off and you leave it for the rest of the night. You don't have to listen to the generator, you don't have to worry about it just running for no reason. So you pretty much run it at like 80% load and then shut it off, and you do that like once a day. So while this is hooked to the power station, you're not able to use the AC input as far as I know, but you can still use the solar, which that's what I'm doing right now. And today it's been pretty cloudy, but I got 6 panels running off of this, 3 panels on each one. So that should be about 2,400 watts, so 1,200 watts a piece. But right now it's really cloudy, so I mean I'm only getting 100 watts on each one, but there's absolutely no sun out right now. But before, when the sun was directly in front of the panels but there were still clouds, I was actually getting like 400 watts per unit. So that's like a third of what it should get, but it was cloudy out. So let's go over the solar part of these. Each unit has 2 MPPTs, and it has this port here. So I just converted that to an MC4 connection. So Anker gives you a connector to convert that to MC4. The only thing about these units, and this is what a lot of people don't like about them, is the fact that you can only put 60 volts input. So that's really low. So in other words, my EG4 18K, that actually has a 600 volt input. So it's 10 times this. So you can run much smaller wire, you can run a lot more panels. As far as the amps, it's about the same. If you're using 11 to 32 volts, you can only do 10 amps. But if you're going 32 to 60 volts, you can do 25 amps per side. So there's a few different things that you can do to overcome this 60 volt limit here. The biggest thing about that is you can't exceed the 60 volts. You can exceed the amps and it will only use what it can. So 25 amps max on each one of these. That's 50 amps altogether. You can exceed that. You can over panel with that. But you got to run all your panels in parallel. You can't run them in series, because if you do, your voltage will be over the 60 volts. So basically the panels that they gave me are like 33 volts. So if you put 2 of them in series, you're going to be over that 60 volts, and that can actually damage this inverter. So the best thing to do is put them in parallel. And you can put 6 of them in parallel, 3 of them on each side here. So if they're 400 watts a piece, which that's what the ones that I have are, that'll be your 2,400 watts. So that's in the best of conditions, you get 2,400 watts for each unit. So it's 4,800 watts between the 2 of them. The reason I didn't run all that, I have 12 panels for it, but the reason I didn't run that is because the panels are on the south side of the garage over there, and this is the north side. So I didn't want to run 1,000 feet of wire back and forth and back and forth. So I ran 2 sets of wires, one for this unit and one for that. And each one of them are like 100 feet long. So you can imagine you just use a lot of wire doing that. But I'm fine with just using 6 panels for now, because the panels are eventually going to go on the roof. So right now it's just kind of temporary. So one thing you can do to get the maximum amount of wattage out of here, if you don't have exactly the right panels, like a panel that was 25 volts would probably be about perfect, because then even in the wintertime when you get a little bit more volts than it's rated for, you'll still be under the 60 volts, and then you can run 2 of them in series, and then you can run 3 of them in parallel. so you can really max your solar out, and you can downsize the wire too. The way that you can get around that is using a solar controller. Like I have a few Victron controllers that are rated for, like one is 150 volts and 70 amps. So you can hook up your panels to that solar controller and then run from the solar controller into this, and you can put it at whatever you want. If you want 48 volts, or if you want 36 volts or 24 volts or whatever you want to do to maximize the efficiency, you can use a solar controller hooked up to this, and then you can use a lot more panels a lot further away with a lot smaller wire, and everything can be more efficient, especially if you have panels that don't really work with the right voltage and amps. You can make them work with a solar controller. So that's one way that I found to kind of get around this. Another thing that I figured out about this unit is it's got this AC input right here, and at first it would only input 1800 watts solid, and I couldn't figure out how to change it. But then I actually installed the app on my phone, and on the app you can select it in 200 watt increments from 1800 watts down to 200 watts. So that was nice, because when you plug an extension cord into this that's 300 feet long, like mine was, or 250 feet anyways, you try to pull 1800 watts through that extension cord, this can sense that it's not getting that 1800 watts, and it will actually shut itself off, which is good because you'd burn your wire out if you try to do that. So once I figured out that you can downsize that, I brought it down to 800 watts, 1000 watts, whatever it was, and then I could steadily input that. So one nice thing about this system is if you have a garage that you already have built and you have, say, like just a 20 amp circuit on it or a 30 amp circuit on it, but you want to run like a welder or something, you don't really want to upgrade your service for one reason or another, whatever the reason is, you can get one of these units, put it in your garage, and it's like a buffer. It's like a capacitor. You charge it up slowly, and then you can output very fast with it whatever you need to do. Like you could even run an extension cord out to your garage if you have no power, and you could use this as your power. You could run a welder, you could run a mini split, you could run whatever, a compressor, whatever you need to do. And you could use this unit to sort of store the energy, because a lot of people, they don't use their garage all day long, so you could let it charge up solar or the AC input, and then when you actually need to use it, it'll be full, and then you can use the full 6,000 watts. Or you could get two of them and run 12,000 watts. Now there is one downfall to using the AC input. If you're using the AC input, you can't use the 240 volt output while you're using that. You also can't use the AC input when you're hooked to that panel. So the way to charge it right now is through that panel. It charges it much faster, actually. You can charge it, I think I saw it almost 3,000 watts or 4,000 watts. It was charging it through that panel from the shore power, basically, you can call it. But let's say you don't have that home panel there and you're just using a standalone unit. You can only use one side of this. So this side right here is the UPS side, which will work no matter what. That will work with the AC input while you're charging the unit. That will work. The right side outlets over here won't work, and these outlets up here won't work while you're charging through the AC input. But there's a way around that as well. What I did is just use a battery charger. I converted a battery charger to this plug right here. That way, because you can still use all the outputs with the DC inputs, you just can't use them with the AC input. So I just plugged in one of these little lithium battery chargers here. This is actually for a 12 volt battery, so you're only able to use 10 amps, so it didn't really put out that much. It was like 138 watts. But if you leave that on all night, that can charge this and still be able to use all the ports. I also have a few more of these that are much bigger than this, and ideally a 48 volt battery charger would be the best. You'd get the most amount of watts going in, and like I said, you could use that. I had it converted to this right here, so you just plug that into there, and then you got AC power going in without interrupting your output. So ideally, it'd be nice to have another battery over there. I'll get another battery to put with that one, because you kind of want to balance them out between the two. I noticed that when I was draining these batteries, obviously that one drained a lot quicker. Like they were fully charged, and now this one's at 69% and that one's at 74%. So I imagine doing that over a long period of time probably isn't the greatest thing. So I'll get another battery like that and put it on top of that one. And at that point I'll have around 15 kilowatt hours of storage. So there's a bunch of stuff that I still want to go over. That's why I waited till the end of the video, because a lot of people don't like to hear a lot of talking, but there is a lot to go over. So this system will obviously back up your power. So in other words, if that power turns off, everything on that panel still works. I'll show you actually, because I got the lights ran off of that panel. So if I shut off this breaker, and this light is run off of this panel too. So if I shut off this breaker, it flickers just a little bit. But now we're running off of just the battery. So we got that light. I installed all the lights up there, so like I said, I got a switch for each light. So we got 1200 watts of lights going right now, which is obviously nothing for this system. Plus we got that light in there going. We got this light right here going. Got some other things charging. So altogether we're using about 1300 watts. So some more neat features about this system is you can do self-consumption mode, and basically what that does is it will power everything in this panel as well, which is the incoming power, as long as the power is going. Right now it can't because the breaker's not on. It senses that there's no grid, so it shuts this panel off. But if you turn that on and it senses incoming power, it will power everything in this panel according to how you want it to. So in other words, it'll offset your power usage. So there's two different ways that it can do that. It can use the solar to input the solar into the system, and then it exports the solar to these two panels, but it won't go beyond this panel because it's got the CTs right here. That's a current transformer, just like on my 18 kPV. So in other words, it won't let power go out from this panel into the other panel. I could extend these CTs over to that other panel, and then I can power everything in the other panel as well, as long as the power is on. So what that does is utilizes the solar that's coming in. So let's say I got 4.8 kilowatts of solar coming in. Well, I can feed that into everything that it needs to, just not exporting to the grid, which offsets all my power usage in this whole building if I ran the CTs over there. But for right now, everything that's in here it can offset. The other mode that it can do is time of use, which if you're familiar with any of this stuff, you know time of use. That's basically when you have the power company charging you a lot more during the day than at night. What this will do, you can set it all up so that it will charge the batteries at night, and then it'll discharge them during the day when the rates are higher. And you don't need solar to do that. You can just charge the batteries with the AC during the night, and then during the day it will just export a certain amount, whatever you want. So basically right now I have it set for, well, I had it set for 40%. So basically it reserves 60% for outages, and it will use 40% to offset my power. So that's for the solar right now. So you can set it to 100% reserved, and then basically it will actually start charging these batteries right now, and it will keep them at 100% all the time. Like if you're worried about power outages, see right now, well, I had 3,200 watts going in, 2,600 and 1,800 coming in on this one. It's charging these right now from that panel until they reach 100%, and then it'll stay like that, and then it won't offset the power. Or you can bring this all the way down to 1%, and you can use 99% of these batteries to offset your power. And the reason why you'd want to use more to offset is because if you have a little amount of storage, then you want to use as much of it as you can to offset your power, because the more you do, the more you save on your bills. Because if you're charging faster than you're using the power, you want some place for that to go, which is storing it in the batteries, and then you want to be able to discharge that. I don't really know where I want to keep this. It really doesn't matter for right now because I'm not using a lot of power, but we'll just keep it at 40% for discharging, for offset usage, and 60% reserved for an outage, which it's the middle of the summer right now, so I don't predict an outage, so we could probably bring that down quite a bit, like 60/40 or something. So there's a lot of other features here too. There's a lot of different stuff. They got a graph that tells you all the different stuff down to the minute. You can check your solar usage. You can check your actual usage for the house, for the day of the week, the month, or the year. You can check each device individually. And like it tells you the temperature of it, tells you the DC input, the output right now. A lot of people will use this for like an EV or something, but you can charge an EV off this. So I guess that would be a thing that you could do too. You could throw this in the trunk of a EV and you could have some extra power on the road. I don't imagine it'll get you too far, but it's something if you put a couple of them in there. And then it shows you the temperature of this unit right here, which even when we were using almost 12,000 watts, this thing was not even warm. So it's got adequate cooling. Another feature about this unit that's kind of neat is that it's very portable. It's got wheels. The wheels lock. You can lean it back. It's got the bigger wheels on the back. You can lean it up. You can actually leave this unit sideways too. Like if you want to put it up on a table or something, you can lean it sideways. There's no problem with doing that. So I guess that's pretty much it for explaining these units, explaining all the different features. We did some testing. So I will leave a link in the description for these, as well as a discount code that you can use to get some money off from buying them. So now let's talk a little bit more about the actual electric that I installed in this garage. Like I explained before, some people are under the understanding that the things that you can do in a house you can do in a garage, which is not the case. So most people would think that you could run number 2 aluminum for a 100 amp service. That's not the case in a garage though, because it's not feeding a dwelling. So you actually have to rate it for 100% of what it's rated for, not 83%. So normally if you're feeding a dwelling unit, they figure that you're not going to be using everything all at once. So you can actually downsize the unit to 83% of what it's capable of. So that's why you can get away with 4-aught for a 200 amp service, whereas with this 4-aught only gets you 175 amps. So normally if you're running a sub panel in a house, you can run 2224, which is pretty popular for a 100 amp panel, but you can't do that in this garage here. That had to be a 1113. So it's number 1 for 2 hots, number 1 for the neutral, and number 3 for the ground. You could get away with a smaller ground and a slightly smaller neutral, possibly, but you have to have at least a number 1 aluminum XHHW for a 100 amp service. And then to transfer the 100 amp service from there to this panel and from this panel to there, I had to use a number 2 copper, THHN. So normally people would use a number 4 for the THHN copper to do 100 amps, but in this case we had to go to a number 2. You could actually do a number 3, but number 3 is not very popular, so you just go to a number 2. So then on the incoming power here, like I said, we got a 150 amp breaker. This is 4-aught, which is quite a bit oversized for that. We could actually change that to a 175, but I'm not going to need that kind of power, especially with that battery backup over there, because that pretty much gives me an extra 50 amps. So I got 150 amps plus 50, so that's like 200. An EGC is an equipment grounding conductor, and that's not your main ground. That's pretty much everything after that, feeding from the main panel to any panel after that. It's an EGC. And you're not allowed to re-identify an EGC from a black wire like this unless it's a number 4 or bigger. So that this is a number 4, so I'm able to re-identify it with that green tape right there. But if it was a number 6 or higher, you would not be able to re-identify it like that. Same thing with a neutral conductor. You're not able to re-identify it unless it's a number 4 or bigger, but this is 4-aught, so that's plenty big enough. So usually for the ground, you'd want something that has a continuous green stripe on it, or it's green itself, or I think even yellow works for that too. So I think that's pretty much it for explaining all of the important details on the electric. I still have a lot more wiring to do, but I wasn't really showing much of that anyways, like the outlets and switches and installing lights and stuff. I wasn't really showing that much anyways, because that's pretty typical. I mean, everybody does that. Even without a license, you can kind of get away with doing that. So I'm sure that's not really too important to most people. I just figured I would show the main important stuff, the heavier duty stuff, like the bigger wiring and the panels and all that kind of stuff, and then obviously the system here. But we still have more lights and outlets to run. I'm going to do some outlets on the outside for charging batteries around the yard and whatnot. I'm also going to put a bunch of lights up there and in the bathroom and the break room and stuff like that, and more outlets up there. And in this room here, I'm not really sure exactly how I want it set up yet because I don't have any equipment to put in there. So things will be changing as I'm going along. And right now, I'm probably just going to get the bare minimum inspected, and then I'll add on to it later. And so that's why I'm not like 100% done with the electric before I end this video. But I figured I'd covered the main parts. So that gives you an idea of how things work anyways. So I guess the only thing left that we have to do now for this video is just wait until it's dark, and then I'll show you guys these lights. So here we are after dark. Let's test out these lights. So we'll turn them on one at a time. Check that out. That is nice. That is all the light I need in here. Like I said, I have every light on an individual switch. And the nice thing is, you pretty much can't get confused about it because the way I arrange these, so this switch set is for the middle lights. This is the back one, this is the middle one, this is the front one here. This is for the left side lights, these lights here, and there's just the back one and the front one. So it's nice and easy to remember that. You're not fumbling around with switches all the time trying to remember which is which. I try to do that whenever I can in houses too. And then this is the same thing. This is the furthest switch, this is the middle, and this is the front switch here. So nice and easy to remember. I still got to put a switch for the outside. I got two really bright lights for up there. Each one of them I think is 20,000 lumens. So we're gonna have one over each bay, and that will really light up everything out there, which is nice. I'm still gonna build some steel benches here, and I'll have some lights directly over top of them like this. I think that's what, like a T4 or something. We'll have that. I'll probably keep a bench here, maybe even just keep it wood. I don't know. I like lots of benches. Got a 100-watt equivalent right there. Still gotta put 3 lights in there, at least for now, probably more later. Lights up there, but anyways, this is what I wanted to show you. No shortage of light in here. So I guess that's it for this video, guys. No fancy outro. I wish you could see the moon, but it never shows up on camera. It's pretty cool. But anyways, the links for the Solix F3800s and these lights are in the description. I have discount codes, so check that out, and I will see you guys on the next video.